Hi, today I'm going to show you how to make a line following robot. This project was delayed because I thought the sensors were broken on this. I explained it on detail on how to use CNY70 video, but I basically needed to replace these two sensors and I thought they were broken while they were not, because they were only detecting black electrical tape and no other black colors, so it wasn't just detecting black colors properly, and I had to replace two sensors, and I also delayed the project quite a bit. So this is why this robot is a little bit late than usual, but let's get started on which parts we need to use to make this robot. So we need two DC motors like this. This is a 600 RPM motor set or robot motor set with a little wheel on here. I actually had to make a modification because the arena that we're going to be using this robot on is paper, made out of paper, and it has black electrical tape on top of the paper, and the wheels, especially this wheel, slip from the paper, so I had to glue a little bit of a hot glue here on this wheel so it would add a little more traction, because this rubber isn't very grippy. It's a little bit grippy, but it's not really grippy, so I used a little bit of hot glue to make it more grippy and add a little more traction on the wheels. So we, as I said, need to use these robot motors, two of them, and we also need to use a 10x10 or 12x10 perf board. I used 12x10 perf board here to make the chassis of this robot, and you can use other combinations as long as the front of the robot isn't longer than 15 centimeters, this side I'm talking about. If it's not longer than 15 centimeters, it's fine to use. Like, you can use 10x10 and around 15x15, and if you use anything within that range, it'll be fine. We don't want to use longer than 15 centimeters because we're going to use a caster wheel, one of these plastic little caster wheels, and these caster wheels cannot really make the robot move properly if the front of the robot is just too long. So we kind of need the robot a little bit short on the front for this caster wheel to steer the robot properly. Talking about caster wheels, we are also going to use a caster wheel. If you don't want to buy a caster wheel, there is some deodorants called roller deodorants, and the plastic piece of them come off. Let me actually show it. I actually used a roller deodorants plastic part as a caster wheel on one of my robots. This is the HC05 Bluetooth controlled robot. You can also watch it on the channel, there's video of it. And you can get these plastic parts from roller deodorants. You can just remove the plastic part, the plastic cap, and just get to this part, which can be used as a caster wheel. Other than that, we also need to use an Arduino. I used an Arduino Nano here. You can also use an Arduino Uno, but the robot may have less space on it to put a battery on it. I recommend you to use Arduino Nano than Uno, but you can use Uno if you only have Uno. It's fine to use both. We also need a small 5x5 perf board to make a sensor board, and we attached this sensor board. I attached it with solder and some wires, some metal wires and solder. Basically soldered two perf boards together and made this sensor board. The sensor board has CNY70s, two of them, and this is basically the cheapest line following robots to make, because there's like very advanced line following robots that can go really fast. This one is going a little slow. It's not very fast, but it does follow a line. So you can only use two sensors, two CNY70 sensors, which are also the cheapest proximity and black and white detection sensors on the market. You can also watch how to use these sensors on my how to use CNY70 video on the channel. We also need to use an SN74 HC14 chip right here to make the analog signals coming from these sensors and convert it to digital. I explained in detail why we use this little chip on my how to use CNY70 video on the channel. I really recommend you to watch that video before watching this video. It will give a lot of important information. And we also use two 10K and two 100 ohm resistors. We also have a 16 volt 470 microfarad capacitor attached to the power lines. Because the motors are making sudden changes and they can create spikes of voltage, and they can also create dips in the voltage when they actuate suddenly, we're using a 470 microfarad capacitor, so this will smooth out the voltage. We're also using an L293B motor driver. I also made a video on how to use this motor driver. I also recommend you to watch that video on the channel. This is the perfect motor driver for a robot, especially for a simple robot like this. Robot is a little bit heavy, but not too heavy. We can't use an L293D chip because that is like very incapable of delivering proper current to the motors, and it usually overheats, so I don't really recommend L293D, but you can use your robot without issues with L293B, which is a lot more powerful than the 93D. We also need some solder and some connection wires, like so, some connectors, some pin connectors to attach the Arduino and make it socketable, and also make the sensor board socketable. And also we're making the L293D motor driver part also socketable, and also the chip itself is socketable, the L293B. And even the CNY70 chip is socketable, it has a socket on it. The only things that aren't socketable or removable are the motors and the CNY70 sensors, and also the caster wheel. We also need a battery pack to power our robots. I used this battery pack on other 3 robots that I have, and I have their tutorials on the channel. I explained how I made this battery pack on the other videos, but if you're watching this as a new viewer, I'm gonna explain it to you. This is basically just an 18650 lithium-ion battery, a 2500 mAh one, which is attached to an 18650 battery holder, and it also has a little hidden TP4056 chip under this Velcro part. With the Velcro, we attach it to the robot, and the TP4056 is to charge the cell up and also give it some protection to the cell. And it also has an XL6009 that is a voltage booster, and it boosts the 3.7 volts of nominal voltage from the battery up to 5 volts for the circuit to use. And it's also, as I said, being switched with this switch here to switch on and off the XL6009. Even when it's idle and it's not drawing any power, the XL6009 consumes a little bit of power and it might drain out the battery. And the connector goes to the XL6009. This is a JST connector, and the robot gets powered from this other JST connector on the other end. I power the Arduino directly from the 5V line, and also the sensor card also from the 5V line, and also the L293B also gets powered from the 5 volts, so this robot completely runs on 5 volts basically. And this is the parts that we need to use to make this robot. So let's demonstrate how the robot works by attaching the battery pack first and connecting the JST connector on the battery pack to the robot and powering it on. So once we power it on, if the sensor sees nothing, it's not going to do anything basically. It's not going to turn on the motors, and if I show one of the sensors white tape, there's 2 CNY70s for controlling the 2 motors. As you can see, when it detects white, the motor starts turning. And also the same thing for the other side, like so and like so. And it can also detect my fingers as white. And if I show both of my fingers, it would make both motors go. And if I show black tape, nothing happens. because the robot will follow black tape. And how it works is it's on a white cardboard or paper. It goes to the side where there is white, and the black tape is being centered on the robot. We're going to see this a lot more clearly when we go on the arena and test out the robot. There are a couple of adjustments you may need to make with the code. I will link the code down in the description, and there is a comment section on the code that is about adjusting some delay functions. So if your robot responds too quickly, you can add a little more delay to that function of the code, and if your robot responds way too late, you can lower that delay function on the code. I will link the code on the description, and there will be a comment part on the code where it says you can adjust this delay function to your robot's own specifications. So let's test our robot on the arena, shall we? So right here is the robot, and this is the arena. The robot will go from there, right there, make a turn, go this way, go, make another turn, and then go this way, all the way to there, make another turn, and go all the way here. And when it sees this black line, it would stop here. So let's see how it works. So I'm just going to turn on the robot right now. As you can see, our robot followed all the lines and came to this line, finish line, and stopped. This is just a stopping line where you just put it on horizontally and both sensors detect black instead of white, and they stop sending power to the motors. You might notice in the video the robot struggled quite a bit on the turns, and that's because the cardboard that I use is warped a lot, and because it's warped it's not like really even or like flat, and the robot's like the front caster wheel is so small that it struggles to get through the corners, and the sensors can't really read it, and the paper doesn't really have good traction on the tires, and it's just not a really good arena. It could have been done a lot better, but this is what I had in resources, so this is what I had to go with. And if I have to show you the amount of warp, you can just see right here. Look at how just inconsistent this is on this turn, and on this turn there's quite a bit of warp, and this part has a massive warp There's actually two cardboards on the back because this was too thin and this was a little bit too thick, so it just didn't go properly and the robot especially struggled here, but it was able to pull it off without too many issues. And the robot struggling to take the corners is because of that, because the Arduino's cardboard pieces are a little too warped to be perfect and the caster wheel is too small to take these corners smoothly. So as you saw, the robot struggled a little bit on the turns, but mostly it did pretty good, even though it was a little bit too slow. This is just only two sensors, and two sensors are just not really enough for going faster, and this is like the most basic and the cheapest robot you can make, and this is pretty affordable to make. The sensors and the parts are easy to find, they're very cheap and easy to configure, but you can add a lot more sensors and make the code a lot more complicated and make the robot go a lot faster if you want, but I just didn't want to deal with that, and the rising cost of the sensors would be a big deal for me. But this is just like a prototype. I can actually improve on it and maybe add more sensors going forward to develop it, but I just wanted to demonstrate how these sensors work and use it in a project, and I think it was a good way of demonstrating it. So this is how you make a line following robot. If you found my videos useful, please don't forget to like and subscribe to my channel, and if you have friends that are tinkering with electronics, you can also share my channel with them, and it would really help me out a lot. So thanks for watching. This is about it for this video, and see you on the next video.